Is it episode 4? Episode 4. Welcome back to Talking Science with Yoks, episode 4. Hi, Ashley.
Hi.
How are you?
I'm good. How are you?
I'm good. Is that your cat in the background?
No, this is a random person's cat. I was gifted this lovely portrait of who I call Tom.
So what does it mean to be a blood and cancer specialist?
For me, it means that I am a medical technologist. So the best way I've learned over time to describe that to people is I'm your laboratory nurse. So I receive any specimens that are taken. So if you have blood taken or swabs taken, I know during COVID we've been receiving a lot of nasopharyngeal swabs, and I test them and I give you your results, and I might diagnose you with something. Hopefully not.
What kind of tests do you have to run?
We have many tests. So I'm split between different areas of the lab. So some of that might fall under our molecular department, and that would include running PCR tests. It might also include, you know, something like genetic testing. And then I also work in our flow cytometry department. So I'm running blood specimens in these little tubes and analyzing a panel of what cells are present.
And you have to be certified as a medical technologist to be in this job?
Yes, so it does require a license, and I'm currently in a training program that will grant me my license at the end of 1 year, and that year comes up in September.
So you did your bachelor's, went to work, and then went back to school for your master's. Did you feel like you needed that advanced degree to be in this field?
Well, um, I'm currently not in a master's program, but I have done a certificate before, and I'm currently applying for another certificate before I go back for a master's. But in this case, I do find it necessary because, my degree in biotechnology is pretty general, and it does give you a good foundation for things in the lab and research and even the medical field. But it did take extra schooling for me to have a little bit more expertise in the medical field itself.
So, from the time you receive a sample, can you explain how the processing happens?
So, depends on what department, but in flow, I receive a blood specimen, and that will have to be processed down to its white blood cell components. Basically, the reason, how flow cytometry applies to my job is that I want to see if a patient has something like a leukemia or a lymphoma. So that would occur in their white blood cells, and we have all these other particulates in our blood that don't really matter to this test. So I process those down, I isolate white blood cells. They get cleaned and thrown onto a flow cytometer. That gets passed through a tube, cells in single file pass through an apparatus and are hit with a laser, and depending on their fluorescent tags, are grouped into characteristically different populations of white blood cells. So you'll have granulocytes, lymphocytes, monocytes, blastocytes, all these different components. And then basically we have our own criteria as to what has clinical relevance in terms of, the diagnostics.
So, with someone with cancer, would you say this is, if they give you a sample, would you say this is the only test they need to find out if they do have cancer?
Depends on what type of cancer. A lot of people, a surprising amount of people, are walking around with some type of chronic lymphocytic leukemia. And that can be asymptomatic or symptomatic, and it doesn't really have too much of an effect on a person's prognosis, but it's just kind of their, their phenotype. But if I'm looking for a leukemia or lymphoma, flow cytometry is probably the best route. I think every sample usually is shared with our chemistry department. There are CBCs that are run, which basically gives you a count of all of the different types of components of your blood, and that can corroborate results. Um, for other types of cancer in our molecular department, the genetic abnormalities are really what we're looking for in terms of prognosis. So if a patient has a mutation in a certain gene, that might be indicative of the progression or the severity, and we can kind of specify treatment based on those results.
While you run these tests that you already have, the protocols that you have in place, are you also trying to figure out better methods to test?
To a degree, um, we definitely have a specific protocol that we need to follow because all of the tests that we run are validated through New York State. And there's different types of licensures that a lab can have, and even just a bench area can have, depending on the test. And we definitely need to follow the criteria that's set by New York State and, again, by our internal standards, because we need to know that machines are running correctly and that procedures are consistent and accurate. So accuracy is really our big concern there. But beyond that, there is definitely room for certain research. We might find that we get cleaner results trying something a little bit differently, but again, that falls within our protocol, and we can adjust from there for sure. And then new testing comes out, and we get new machines, and we validate all those machines. So the field is definitely progressing um, very rapidly.
Is there a type of machine, like you were saying, that you would want to see to make your work easier and more accurate?
Well, that's a really good question. I definitely, I've experienced at least one machine as of recently that I never experienced in research before. Just a typical DNA, RNA extraction, and it's all automated. And I think that this is like the coolest advancement rather than like our typical chemistry way of extracting DNA and RNA through like a million centrifuge steps and just adding chemicals and passing it through a filter. This is really all automated by like my magnetic rods, and it's attaching to DNA, and it makes everything so clean and it's so consistent. You eliminate so much human error. So any machines that kind of um, are able to eliminate that human error in pipetting or whatever is just, that's all I want to see. I think that's amazing.
What does a typical day look like for you? Or do you have a typical day?
I have several typical days. um, and that's also changing kind of rapidly now. I've kind of informally getting my feet wet into a supervisor position before I advance, but that includes kind of building a new lab and getting in new equipment and finalizing licensure and submitting paperwork to New York State. But a typical day, I'm usually bouncing around between departments, just trying to be most efficient in getting all of our flow specimens processed. We can have somewhere up to like over 100 a day, analyzing those cases. And then I will probably go upstairs to Prosigna and isolate some RNA and look at any genetic mutations there, um, and then getting new equipment up and running and validated.
So, from the time you receive a sample, how long does it take for you to get the final results?
Depending on the sample, because there's, like I said, there's many different tests. So in flow, if I have a little lavender tube of blood, that will only take a day for the results, from processing through to analyzing, and then that's also passed to our hemopathologist for her final say. Yeah, that'll only take a day. But for Prosigna, which is a test that isolates RNA from breast tissue, specifically from women, I think ages like 50 to 75, something like that. Um, that's a 3-day process, from when we receive the sample to when we actually have the automated output of what their score of reoccurrence would be. And I think for our MPN panel, which isn't yet up and running, that's also a 1 to 2 day process.
What is an NPN panel?
MPN is actually a test for myeloproliferative neoplasms. So people who are diagnosed with some type of myeloproliferative disease, we do a test of a panel of 5 different genes to detect any type of mutation. Luckily, those are very low. So I think about 80% of cases are typically negative for these mutations, but like I mentioned, mutations in any of these 5 genes are indicative of prognosis.
Do you miss working with zebrafish?
The zebrafish, yeah, a little bit. Although you come home and your clothes are soaked, and half of the hatchlings died for no reason. They're very cute though, and I think that there's such a great potential for zebrafish in research, just because they're so quick to develop. It's easy to watch them develop. They take very well to CRISPR, um, but I definitely would rather work with zebrafish than mice, which is what I was doing in my past 2 jobs. Like, oh, they're so cute.
So if somebody wants to go into this field, where do they start?
There's a couple starting points. The one that I probably regret the most, only because I didn't know that it existed, the best way I think would be to start is in an undergraduate program for clinical laboratory sciences. That's probably your easiest way of getting your feet wet in all of the different departments, and also where you can prepare to take an ASCP certification exam, which would give you national recognition for your license. My route is different, although it's unconventional. I think it still fits me, personally very well, because my main interests lie in molecular flow cytometry and cytogenetics. So I had a couple years of research, both at Harvard and then at Cold Spring Harbor, just in molecular labs, also studying cancer. And so, given that laboratory experience, I was hired at New York Cancer and Blood Specialists and entered a training program through an application to the New York State Department of Education. They issued me a training certificate, and at the end of the year, I'll have my license in molecular. And then I can apply for flow, and that's definitely one route to take. And personally, I want to go back to school for this new certificate program so that I can have a good foundation in these 3 departments, and then further advance to a master's again in the same areas.
So when you take the ASCP exam, there's so many different certifications. Is there one that would encompass everything? Or is it just completely different from each other?
Yes. So the reason why my case is different is because I didn't go for a full generalist license. A generalist license is what you could, take an exam for after your 4-year degree in clinical lab sciences. And that encompasses, I believe, chemistry, histology, flow, molecular. Um, I'm probably missing something else, but it encompasses all of the departments that you could potentially work in. Oh, there's also blood banking. A lot of these jobs are, or this program is really preparing you to work in many different settings. So you could work in a hospital, or you could work in a private clinic, something like that. So that 4-year degree would prepare you for the full large exam. In my case, I'm taking specialist exams.
And how many hours of hands-on work do you need to have for that?
I'm not sure of the hours, but it depends. For molecular, I'll just be granted my license in molecular after this 1-year program. For New York State specifically, flow cytometry and genetics are considered specialty exams. So you can only take them after you have about 5 years of experience in those fields, which is fine. But again, you can take schooling, you can take certificate programs or a master's or something that'll prepare you for those.
So I want to talk about mind and body transformation. I have watched you over the years become a stronger person, both physically and mentally. Do you want to talk about what your journey has been like?
Thank you. Yeah, sure. I mean, it's I guess for me, it was a big part of just kind of trying to grow up a little bit. I'm still very much a child in a lot of ways. But I think one thing that, was really just kind of like a big turning point for me was when I was living in Boston. And I really didn't have too many friends. It was a new city. I didn't really know anybody. Um, and I wasn't feeling super confident in myself, again, because I'm also starting a new job that I didn't have too much experience in. I wasn't sure how I was going to do. So part of building my confidence was setting a goal and saying, you know what, I'm tired of this. I want to feel good. I want to be confident in who I am. And so I started exercising, and I chose to start working out at 5 a.m. just to kind of give myself a good start for the day, maybe quell some anxiety. And I found that the exercise that I had started incorporating into my routine, I was feeling in other areas of my life. So I felt like I had more brain power, like this big cloud kind of lifted. And I had so much clarity in learning. I had energy to stay awake while people were trying to teach me things. um, and then, all the things that come with that is, you start feeling good and you're eating healthy, and everything just kind of falls into place from there.
Anything else that you want to talk about that I didn't ask?
Yeah, I guess the only thing I would really try to highlight, because I mean it's something that I wish that somebody had told me, was just you know your worth, and you know what you want to do in life, and you can't let people tell you that you can't do it or you're not smart enough or whatever. I've had experiences like that. When I first moved to Boston, I was actually working at Boston University, and I was in a very, very small lab, and there was no guidance and there was no mentor for me, straight out of college. And I was told that this field was not for me. And it does get better. I'm in my current role now after working really hard and believing in myself. And I have my director giving me letters of recommendation. She wants me to go to school. She sees me as a good fit. You can't let people bog you down. It's a tough field. And also apply for clinical laboratory sciences. It exists. It's a cool field to be in.
Well, thank you so much, Ashley, for doing this on your day off.
Sure, of course. I love talking science. I'm so glad you reached out too. It's so good to hear from you.
You too.